Okay, today I'm going to do exercise 13.3, example 1a. Alright, first, right, if you notice for the R formula which we just went through just now, okay, for the R formula, notice the coefficient of cosine theta is 1, the coefficient of sine theta is 1, and also we know that by the R formula, okay, if cosine is in front, straight away I know that it becomes R cosine, okay, theta. For cosine, right, the plus will become a minus alpha, like that. Okay, so you must be able to at least write down that the 1 cosine theta plus 1 sin theta is R cosine theta minus alpha. Then very quickly now, let's find the value of R. R is equals to 1 square plus 1 square, square root. Okay, R is equals to square root 2. There is actually no need for you to go and evaluate this square root 2. Just leave it as a square root 2. It's fine. Okay, a surd form is an exact form. Next thing is this: alpha is always b over a. Always take the absolute value. Just ignore the sign. This plus or minus will already be accounted for here. So in this case, what we have is tangent alpha is equals to 1 over 1. This one b over a is 1 over 1. Alpha is inverse tangent of 1. Alpha is 45 degrees. Therefore, cosine theta plus sine theta will be equals to square root 2 cosine theta minus 45 degrees. And we are done with question 1a. Now we do question 2. Okay, question 2. Question 2, it states that given that 5 sine theta minus 12 cosine theta equals R sine theta minus alpha, so 5 sine theta minus 12 cosine theta is equals to R sine theta minus alpha. So our mission is just to find R. Okay, simply R is equals to a square, in this case a is 5, plus b square, square root. My R value is simply equals to 169, square root is 13. Next thing we want to find alpha. Tangent alpha is equals to b over a. In this case, b, right, is 12, a is 5. We ignore the negative sign because we just take the b. The negative sign is already accounted for in the formula itself, this negative sign here. So we just simply take b over a, 12 over 5. So alpha is inverse tangent of 12 over 5. So what we get is inverse tangent 12 over 5, 67.380 degrees. Okay, we leave it in truncated form first, but for the final answer, 5 sine theta minus 12 cosine theta is equals to 13 sine theta minus alpha, which is 67.4 degrees. Just leave the truncated answer there, because in the future when you need to make further calculations to calculate certain equations or to solve certain equations, you will need a truncated value. But in this case, this is the final answer. That's why I rounded it off to 1 dp, since it is a question in angles, so it's 1 dp. But as I say, truncated answer is required sometimes, okay, for solving. We will see it in a later question. Now we will do question 5. Okay, question 5 works like this. They say solve an equation. So I get square root 3 sine x minus cosine x equals to 1. Okay, now we can't just solve this equation because we need to combine these two terms into one trigonometric equation so we can solve it. So the first thing we do is we will try to express these two, okay, into one trigonometric function. So what I do here is this: I write R sine theta, or in this case is x, okay, r sine x minus alpha is equals to 1. So one sine term, one cosine term, we can combine it into one single trigonometric function. So now, to find r is equals to square root 3 square plus 1 square. Square root the whole thing. Okay, don't worry about the minus sign, it's already accounted for in the formula itself. That's why I just put in here b is 1, I just put in 1 down here. So r is equals to 3 plus 1, 4 square root. R is equals to 2. Now, tangent alpha is equals to b over a. Again, we ignore the negative sign because the negative sign is already accounted for in the formula itself. So I just take b over a. I take inverse tangent of 1 root 3. Inverse tangent of 1 root 3. Down there. What I get is 30 degrees. Down here. So I get alpha is 30 degrees. So this whole term, okay, I fit in r value and alpha value. So I get 2 sine x minus 30 degrees is equals to 1. Then we solve it as per normal. Sine x minus 30 degrees equals to half. I inverse sine of half, okay, but wait, they say that they want you to solve from 0 degrees to x to 360 degrees. So we revise a bit of last year. 0 x 360 degrees. Okay, what am I doing here is trying to see the range of values. So just like last year, we will adjust the range of values. Is x minus 30, so here I'll find x minus 30. So minus 30 degrees, x minus 30 degrees, 330 degrees. Okay, so I have these things there. Then now, let me try to do this. Okay, so first, from here, you inverse sine of half, or this is revision. If you can't remember, better go back and look at your old notes. Is 30 degrees. So 30 degrees, sine is positive, okay, it should occur in the first quadrant, okay, AS, and the second quadrant. Because the angle, okay, is 30 degrees, it should occur in the first and second quadrant. So for this, I inverse sine half. I get the first quadrant, which is 30 degrees, and the second quadrant, 30 degrees. So my two angles, okay, will be here and here. So my first two angles will be x minus 30 degrees is equals to 30 degrees. Check, is it still in the range? It's still in the range. Next angle I have is 150 degrees, still in the range. Okay, now negative 30 and 330, we better check. 30 plus 360 is 390, out of range, we don't care. 30 minus 360 degrees, you go one entire round, is minus 330, out of range, we don't bother. 150 plus 360 is 400 plus, okay, 500 plus in fact, out of range. 150 minus 360, also out of range. So these are my only two values. So in the end, you add 30 on both sides of the equation, I'll get x is equals to 0 degrees, or x is equals to, x is equal to 60 degrees. 30 plus 30 is 60. Then 150 plus 30 is 180 degrees. And that solves question 5.